Okay, so today we're going to learn about trig, double angles, and half angles identities. So before we do any problems, let's go over the double angle identities and half angle identities. So on the left side we have the double angle identities where you have sine 2x equals 2 sine x times cosine x, and then cosine 2x equals cosine square x minus sine square x. You have like 3 different cosine 2x, so the other one is cosine 2x equals 2 times cosine square x minus 1, and then cosine 2x equals 1 minus 2 sine square x. And then the tangent 2x equals 2 tangent x divided by 1 minus tangent square x. And then we have half angle identities, so the first one is sine x over 2 equals plus or minus square root of 1 minus cosine x over 2, and then we have tangent x over 2 equals plus or minus square root of 1 minus cosine x divided by 1 plus cosine x, and then cosine x over 2 equals plus or minus square root of 1 plus cosine x all over 2, and then tangent x over 2 equals sine x divided by 1 plus cosine x, and then another tangent. So we have like a total of 3 different tangent. So the last tangent is tangent x over 2 equals 1 minus cosine x divided by sine of x. Okay, so let's start doing problems. So the first problem says, find sine of 120 degrees, cosine 120 degrees, and tangent 120 degrees by using double angle identities. So we want to find the sine of 120, cosine of 120, and tangent of 120. What I know that we can say, let's say x equals 60 degrees, since two times 60 is 120 degrees. It'll just make things much easier. So I'm going to use one of the double angle identities. I'm going to use this one. I'm going to use sine of 2x equals 2 sine x cosine x times cosine x. Okay, so all we got to do is plug it in. So sine of 120 degrees. So because 2 times 60 is 120, and then 2 sine of x, which is 60 degrees, not 120, so 60, and then times it by cosine of 60 degrees. So sine of 60, so it's 2 times sine of 60 is root 3 over 2, positive root 3 over 2. And then cosine of 60 is 1/2, just 1/2, positive 1/2. And when you do the multiplication, so 2 times root 3 times 1 is 2 root 3 over 4, and that simplifies as to root 3 over 2. That's your final answer. This is just for sine. Now let's do the cosine of 120. So I'm going to do cosine of 120, and I'm going to use this identity, cosine square x minus sine square x. Cosine square x minus sine square x. So cosine square of 60 degrees minus sine square of 60 degrees. So cosine of 60 degrees is 1/2. And then make sure we have to square it because we want it squared because the cosine. And then sine of 60 degrees is √3/2. And then make sure you square that as well. So that's 1/4 minus square root of 3 squared is 3 minus just over 4. So it's 1 minus 3, which is -2 over 4, and then that simplifies as to negative 1 over 2. That's -1/2. So we did the sine, cosine, now we got to do the tangent of 120. So I'm going to use this formula, this double angle formula. So I'm going to use actually 2 tangent x over 1 minus tangent square x. So we just got to plug it in. So plug in our x. So 2 tangent of 60 degrees. 1 minus tangent square of 60 degrees. So let's simplify this. So tangent of 60 degrees. So it's 2. If you want, you could draw the circle if you don't know it. So here's 60, 30, 60 is right here. And that has a coordinate of 1/2, comma √3/2. So this is your x and this is your y. So tangent is y over x, so this is 60 degrees. So y is √3/2 over 1/2. And then I'm not going to simplify, I'm going to later on. So 1 minus tangent square. Yeah, let's simplify first. So let's get rid of this 2's. So that's 2 times √3. Yes, 2 times √3. And then tangent of that, we said that we agree that tangent of 60 degrees is just √3, because that's what we got here. And then make sure you square that. Let's simplify. So the numerator is 2 √3, 2 times √3, over 1 minus square root of 3. Square root of 3 squared is 3, so 1 minus 3 is -2. So these 2's cancels, and then you're left with -√3. And that should be your final answer. Good. Next problem. Use half-angled identity to find the exact value of cosine pi over 8. So we got to use the half-angle identity to find the exact value of cosine pi over 8. So I will not use pi over 8, I will use pi over 4. Because I'll use pi over 4 because pi over 4 divided by 2 gives you pi over 8. So I will use this formula, this half-angle identity. So I'm going to use cosine x over 2 equals plus or minus the square root of everything, 1 plus cosine x over 2. So, we'll just have to add in and plug it in, so plus or minus 1 plus cosine of pi over 4, not pi over 8, over 2. So that equals plus or minus square root. And the cosine of pi over 4 is square root 2 over 2, all over 2. And then let's say 1, same thing as 1 is 2 over 2, right? So we could say plus or minus, so 2 plus square root of 2 is 2 plus root 2 over 2, and then divide that by 2. If you put a 1 over here, and if you were to do your brackets, right, so you have a 2 and a 1, let's multiply everything by 2. So this 2's cancels, and then then you're left with plus or minus square root 2 plus root 2. Don't forget, okay, so now it's 2 times 2, which is 4. Notice on the left we have two answers, plus or minus. I will use positive plus positive because since pi over 4 is in quadrant 1 and cosine is positive, that's why I'll use positive. I will not use negative, so I'll put it right here. Since pi over 4 is in quadrant 1 and cosine is positive, so that's why I'm going to use only the positives one. So that simplifies us to the numerator. Notice how we're going to have like a numerator and denominator, so it's a square root of this whole thing, so square root of 4 is 2. So on the numerator we have square root 2 plus square root of 2, and then square root of 4 is just 2. Hey, that's your final answer. Next one. Use the half angle identity to find the exact value of sine 75 degrees. So the sine of, I will not use sine 75. I'll use x equals 150 because 150, since 150 over 2 is 75. So our x is 150 value, so remember that. So it's really simple, you just gotta do sine of 75 degrees is, hold on. Just make sure you don't get confused, it's 150 over 2 because that's one part of the formula. It's x over 2 equals plus or minus square root of 1 minus cosine of 150 over 2. Okay, so that equals plus or minus cosine 1 minus cosine of 150 is negative root 3 over 2, so it's 1 minus a negative root 3 over 2 divided by 2. So that becomes positive, positive. And for this 1, let's just use 2 over 2, because that's the same thing as 1. So that simplifies as plus or minus 2 plus root 3 is 2 plus root 3 over 2 divided by 2. Give it a 1 here. And if you were to do the brackets, you have a 2 here and a 1 here, so we're going to multiply by the GCF, which is 2. So over here, it's plus or minus. These two cancel, so on the top you get 2 plus root 3 over, and then 2 times 2 is 4. Let's see, now we got to figure out, are we going to use positive or negative? Since sine, okay, so I'm going to use positive because since sine of 75 degrees is in quadrant 1, the sine is positive. Sine is positive. So positive. So this, on the numerator, you're going to get a numerator and a denominator, so the numerator is square root 2 plus square root of 3, and then the square root of 4 is just 2. And that's your final answer. Okay, this one says, use the half angle identity to find the exact value of tangent negative 15. So note, I will use x equals negative 30, because when you do negative 30, since negative 30 over 2 equals negative 15, so I will use this formula, tangent x over 2 equals plus or minus. You can use the other tangent if you want. I'm just going to use this one. Actually, hold on. I will use this formula. Tangent x over 2 equals, because I don't want to use the square root because it's going to get messy, so I'll use this one. Sine x divided by 1 plus cosine x. So that equals sine of negative 30 divided by 1 plus cosine of negative 30. Yeah, because our x is negative 30. Let me draw the triangle if you don't know. So we gotta figure out, so negative 30 is right here. This is negative 30. It's also negative pi over 6. And has a coordinate of positive root 3 over 2, because cosine is positive. And then negative sine of negative 1/2, because sine is negative. So, good, we just gotta plug it in. So sine of negative 30 is negative 1/2 divided by 1 plus cosine of negative 30 is positive root 3 over 2. Let's focus on the denominator, and then let's simplify the denominator. So that 1 could be the same as 2 over 2. So that's, on the numerator, we're still left with negative 1/2 divided by 2 plus root 3 over 2. These 2's cancels. So on the top, you're left with negative 1. And the denominator, you're left with 2 plus root 3. Let's rationalize the denominator by multiplying the conjugate of 2 plus root 3. So the conjugate of 2 plus root 3 is 2 minus root 3. So that's negative 1 times 2 is negative 2. And then 2 negatives is a positive, so it's positive root 3. This is the perfect square, so it's a squared minus b squared. So our a squared is 2, so that's 4. Minus, and our b is square root of 3, and you square that, that's just 3. So that's negative 2 plus root 3 over 1. So our final answer is just negative 2 plus root 3. And yeah, like I said, you can use the other tangent half angle identity, but I'm using this one in particular because I don't want to deal with square roots. Number 5, example 5. Find sine that's not x, it should be alpha. Find sine alpha over 2 given that sine alpha equals 3 over 3/5 and alpha is greater than pi halves and less than pi. So first step I'm going to do is I will use this formula. This sine of alpha over 2 equals plus or minus 1 minus cosine alpha over 2. Okay, if I'm going to use this formula, I have to find cosine and alpha, right? We don't have that. So to find cosine of alpha, we're given that sine of alpha equals 3/5. This was given. So we could find cosine alpha really easy by using this formula. Remember, sine square x plus cosine square x equals 1. So we know our sine is 3/5. If we square that, and then plus cosine square x equals 1. So 3/5 squared is 9 over 25 plus cosine square x equals 1. And then subtract this. (9 over 25). So to make it simpler, on the right side, 1 is the same thing as 25 over 25, right? So cosine square x equals 25 minus 9 is 16. divided by 25. And then let's take the square root. So cosine of x equals, now notice we get two answers, plus or minus. The square root of 16 over square root of 25 is 4 over 5. Okay, so we gotta figure out, are we gonna use positive or negative? So we said that alpha is greater than pi over 2 and alpha is less than pi. So let's kind of draw it to give an idea. So here's pi halves, here's pi. So they said it's greater than pi halves and then less than pi. So less than pi. So we can only use quadrant 2. In quadrant 2, cosine is negative, right? Yes, cosine is negative. So we can only use negative. So we can't use positive. So cosine of alpha is negative 4/5. So now we got what we need, so we'll put it back in this formula. So that equals plus or minus 1 minus cosine of alpha is negative 4/5, so there's another negative 4 over 5 over 2. This becomes positive. Let's fix the numerator. So 1 is the same thing as 5 over 5. So that's plus or minus 5 plus 4 is 9. 9 over 5 divided by 2. Put a 1 here. So you have a 1 and a 5. So your GCF is, we're going to multiply everything by 5. So that 5 cancels, you're left with a 9, and then 5 times 2 is 10. So over here we have plus or minus 9, and then 5 times 2 is 10. We got to figure out, are we going to use positive or negative? Since we can only use quadrant 2, right? Sine is positive, right? In quadrant 2, this cosine is negative and the sine is positive, so sine is positive. We can only use positive. So we're going to use positive. What is the square root of 9? Is 3. And then the square root of 10 is square root of 10. We can rationalize the denominator, so we'll multiply everything by square root of 10. So you're left with positive 3 times square root of 10 is 3 square root of 10. And then square root of 10 times square root of 10 is just 10. And that's your final answer. That was example 6. So it says here we got to prove that the following equation is an identity. So we are given sine of 3x equals sine x times this whole thing, 3. So we gotta prove this is an identity. So when we have to prove this, we gotta have to make the left side equal to the right side, right? Or the right side equals to the left side. So they gotta equal the same size. So I will start with the left side. Let's look at this. Yeah, let's look at the left side. So we have a sine of 3x. We can also write a sine of 3x as sine of 2x plus x, right? Yeah, we can. So this sine of 2x, remember from the last section we went over sine of some identity, so we can use that formula. We'll use the sine of some identity. So the sine of some identity looks something like this. This is review, sine of alpha times cosine beta plus cosine alpha sine beta. So we said that alpha is 2x, and then our beta is just x. So sine of alpha is 2x, and then cosine of beta is x, plus cosine of alpha, cosine of which is 2x, and then times it by sine of beta, which is sine of x. So we have sine of 2x times cosine x plus cosine 2x, and then times it by sine x. Hey, this looks familiar. This sine 2x, and then this cosine of 2x looks very familiar. It's also known. It's one of our we could use. Those are our double angle identities. So we can simplify this even more, so let's put it down here. So this sine of 2x is a double angle identity, so we can rewrite it as this sine of 2x is the same thing as 2 sine x cosine x it's x, not alpha, and then bring down this cosine x, so it's just times it by cosine x. Good. So we've done the left side. Now let's do the right side. So this cosine 2x is the same thing as cosine square x minus sine square x and then bring down the sine x. Let's simplify. So we have 2 sine x times cosine x times cosine x. So this 2 sine x, and then cosine x times cosine x is cosine square x plus now we have to distribute this, so that's sine x of sine x, not alpha, times cosine square x minus sine square x times sine x is sine cube x. Now let's simplify. We can actually, let's see, oh yes, we can simplify as, See how there's a 2 over here? We have a 2 sine x times cosine square x, and then we have a 1, invisible 1 right here, sine x times cosine square x. So that's like saying 2 plus 1, which is 3. 3 sine x cosine square x. And then this, then you're left with a negative sine cubed x. And then finally, we could actually factor out a sine x. So our final answer should look something like this. Sine x times that by 3 cosine square x minus sine square x. Hey, this one now looks like on the right side, so that's how we know it's an identity, so it's true. Because the left side equals the right side. Let's do the last one, the final one. Same idea, prove that the following equation is an identity. So for this one, hold on. Oops. So for this one, let's use tangent x over 2 plus cotangent x over 2 equals 2 cosecant x. So we gotta prove the following equation is an identity. So I will start on the left side, and then so I will start on left side, and then I will use two different half angle identities. So use two different half angle identity. So this tangent x over 2, we say that as sine of x divided by 1 plus cosine x plus, okay, so for this part, this cotangent x over 2, I could use this identity, 1 minus cosine x. This is a tangent identity. Yeah, this is a tangent, not a cotangent. But notice for cotangent, all you got to do is switch the x and y's, because cotangent is x over y. So we just got to flip it. So this will be sine x divided by 1 minus cosine x. So that's how I got this equation. So we're going to put that over here. Sine x divided by 1 minus cosine x. Okay, so now I'm going to multiply the top and bottom by the common denominator. So for this side, I'm going to multiply it by 1 plus cosine x. And then over here, we're going to multiply it by 1 minus cosine x. Okay, so let's do the left side. So let's start with the numerator. So 1 times sine x is sine x. And then minus cosine x times sine x. plus, and then sine x times 1 is just sine x. And then plus cosine x times sine x. All over the common denominator. So that's 1 minus cosine x times 1 plus cosine x. Now let's simplify. Let's simplify the numerator. So this cosine x times sine x and this negative cosine x times sine x cancels. So we can get rid of this. So we have sine x plus sine x, which is 2 sine x. And then if you multiply this, it's a perfect square, so it's a square minus b squared, so it's 1 minus cosine square x. This is an identity, right? We get it from cosine square x plus sine square x equals 1. So if you were to subtract cosine square x from both sides, you get sine square x equals 1 minus cosine square x. So over here, on our new denominator, we could put sine square x. So the numerator stays the same, so 2 sine x divided by sine square x, because we got it from this formula. So the sine x, one of them cancels, so you're left with 1 on here. So that becomes 2 over sine x. This can be simplified even more because cosecant x is 1 over sine x. So we could rewrite it as 2 times cosecant x. And voila, the left side equals the right side. So this equals the right side. So that's how we know it's an identity. And that's it for today.